Hi, my name's Tom Pandolfi, and here at Sharp 5 we've built some interesting models that you can play with on the internet. If you want to go and look for yourself, you can see them at www.colab.com/learn. So, this is an interesting model that I built. The way this works is I've got these two masses, these black circles are masses, and I can change the size of the mass, each one. So you can move the masses around if you want to. The green circle lets you move them, and the green arrow lets you change their direction. So let's put them fairly close together. And they're almost the same size, but I don't want them exactly the same size. And I'm gonna have this mass head that way and have this mass head that way. And you can see the green lines are which way they're going to go when they start moving, and the red arrows are their attraction. So the red arrow always points together. It kind of jumbled up there. You can see when they're further apart, their attraction is less. When they get closer together, their attraction gets larger and larger. Now, these masses will never collide. I have it designed so that they can go right through each other without colliding, because they're just representing what would really happen. So the equations for orbiting and moving are the correct equations, but it's a simulation. Now what you can do is you can after you've set the masses and you set the direction, you want to do an experiment, you hit the start button. If at any point you want to see what's going on, you can hit stop. Now you can use the wheel. If you have a mouse wheel, you can use the wheel to zoom in and zoom out. So let me zoom out a little bit before I start it. So here we go. Let's see what happens. Now you can see the blue line is their path. Let me zoom out some more so you can see where that guy's going. So you can see this guy is much heavier, and so he's not moving as much as the little guy. The little guy has moved out, but he's still being pulled back. And the little guy is pulling the heavy guy towards him, so they're going to go past each other again. So these two objects, whether they're stars or planets or whatever, doesn't really matter. But basically they're they're interacting with each other. So if you were trying to slingshot a satellite out of the solar system and you wanted to run it past past Jupiter or something like that, this would be a way to test your theory to see if you've got your equations right. So let's go back to the beginning again. So if I hit reset, now I can move them again. So let's try this. Let's make one smaller, much smaller, and make one bigger. And see what happens this time. I'll leave the directions the same. Here we go. Wow, I really shot it out there. That's too far. Let's try it again. That's the fun thing about this. You can keep playing with it. So let's change the velocity to make this guy head that way and see how it goes. I guess having that one smaller really slingshots it out. Let's go again and only make them about the same size. So one is 4,000 something and one is 3,000. So they're not quite the same size. Let's try that. Slowing down. They're still moving pretty good though. So let's try again. And this time let's put this one out here and have him head toward that guy. Put this guy over here. See how they dance now. because they're about the same mass, their path looks symmetrical. I guess it's also based on where I started. The arrows were a mirror image of each other. Okay, so to go and play with this on your own, go back to the beginning of this video and look at the URL to find out where to go on the web, and have some fun.